today we're going to modify something we've already done in the past, and that is this bit of hardware right here. We're going to, instead of pulling our steps and our control from a computer screen like you're seeing right now, what we want to do is we want to pull that information from a file. So for example, if you are running a light show, you want to put in the program in a file so that you can just start the file running and it'll pull the information from it and it'll move the stepper however you pre-programmed it to. Or maybe you have theater and you want to do lights in a preset way, or maybe you've got a Mars Rover that you know is 12 light minutes away on Mars and you need to store the steps for the rover to move or whatever function it's going to do. So you want to pull that from a file and not have to enter it into the screen like I'm doing right now. Okay, so that first one is the mode. You can see mode there on the screen, and I'm using mode 0, which is the coarsest. The next line is the degrees per step, and this motor is very old, it's very crude, it's a 7.5 degree per step. Newer ones get as small as 0.45 degrees per step, and common is to have like 1.8 degrees per step. So the next one I haven't put in yet is the direction, clockwise or counterclockwise, and put in a 0, which is counterclockwise, and the last one is the speed. It's sort of like percent, so the default is 50% of the total speed or the maximum speed. And again, then we're going to run the program or run this set of code, and that's it. So it'd be nice to have this from a file instead of having to enter it on the screen every time.
Let's take a quick look at the Python 3 program behind this, and I'll go through it quickly because this is pretty much a repeat of the other software that I did for the 8825, so I won't bore you with repeating all this stuff again. But up here we have the comments telling me what all these things are, how I set it up. Here's the import time because we need the sleep function, GPIO because we have to do the GPIO stuff. The first step is opening the file. So this is my input file, and this is the first difference between the two. Open it for read. This is all the same. This is my direction pin, my step pin. These are some other things: not sleep, not reset, not enable. These are pins I either need to hold high or low to make it function. Here's where I set those. These are the mode variables, and these are the pins that the mode is going to. The mode is the step mode, so it's how fine a step. So it's either, in the case of this stepping motor, 7.5 degrees per step, and it can be set to 1/32 of that. So anyway, this is the table of possible values, and here's where things get a little different. So this is the beginning. We're going to have a long loop. It's going to start right here at the 4, and it's going to run down to right here, and this is going to loop around until the data in the file is gone. So that's one big difference. Okay, let's go back up and look what's going on. The first thing I'm going to do is I'm going to read the first line out of the file. I put a header in the file so that I can remember what the variables are. So later when I go look at the file, I won't say what was this file about. It'll actually tell me at the top. So this slews the first line. Now I begin the loop, and this loop is going to happen for every line in the input file. So the first one says, okay, go get a line. I'm going to reset my variables, which I didn't have to do last time because, well, I was only going through it one time, so I didn't need to worry about it. So I need to reset these every time, so I clean these out. Then I'm going to take and I'm going to grab this line that came in from the file, and I'm going to turn it into a string. It's going to be a string of numbers, but technically it's a string. And I'm going to split them on spaces. Now I'm going to go down here and I'm going to use the same logic as I did before to validate the incoming data, because I want to make sure that I do not have, strange values and cause the program to choke. That it will default to certain values. So if I get an invalid, say a clockwise, counterclockwise direction value, it will default instead of bombing. Okay, so I'm going to get like mode in, and that is the step mode. So 1 step to 1/32 of a step. The degrees, 7.5 degrees per step in my case. The rotation, how many rotations am I going to do? So this could be 1,000, it could be 1, it could be 0.0001 rotations. Rotation direction is going to be in position 3. So each one of these are the positions of the number from the file. So this is 0, 1, 2, 3. Down here to rotation direction is in position 3. And rotation speed is in position 4. I'm going to take that. Again, I'm going to go through here and validate this. For example, I won't go through all of these, but for example, the mode in, the valid modes are 0 through 7. If it's not valid, I'm going to default to 0. That's arbitrary, but okay, fine. It'll at least keep the program running. All of these, the degrees have to be right, the float, and if the data is invalid, it will set a valid default. So direction, for example, has to be either 0 or 1, and if it's not 0 or 1, then it's going to set it to 1. Rotation speed has to be between 1 and 101, and this is where I set the rotation speed. Let's see what else. Print. This is a print statement. It's a debug statement I forgot to take out, but okay. Now we're going to go down and we're going to set the GPIO ports. Now this is different than before, because before, when I was only executing the commands from the screen, I only had to do this one time. But now it's got to be in the loop, because I got to check and make sure this is happening every time. So direction, rotate direction. So this comes from above. We're going to put that in there and set this to be a either 0 or 1. And so based on whether it's 0 or 1, it'll rotate clockwise or counterclockwise. We're going to set the not sleep function to true because we do not want it to sleep, the not reset to true because we do not want it to reset, the not enable to false because we want to enable it. And then we're going to set our 3 mode pins. So again, this is where the mode goes to determine whether it's 7.5 degrees per step or 1/32 of that per step. So this is where that happens. Down here, we finally get to the place where we're going to rotate the shaft. Yeah, I know, after all that code, this little bit is what actually rotates the shaft. So, for the number of steps that we calculated, we're going to take the step pin, we're going to turn it true, then we're going to go to sleep, and the faster we want it to rotate, the less sleep time. Then we're going to set it false. So one iteration of this gives 1 step. Now it can be 1 step of 7.5 degrees, like with my stepping motor, or you can set that to 1/32 of 7.5 degrees. So, but again, this is where it's happening, it's zipping through that. And when the outer loop, the main loop, starting up here, down here, when it runs out of data from the input file, it's going to drop through. And when it drops through, we're going to reset the 8825. We're going to do a GPIO cleanup. In other words, we're going to reset all those ports. We're going to do a file close to close the input file. We're going to print done to let us know that the program finished normally. And that's it for the software part of this. This is the input file. This first line is just a reminder so that when I'm making data points I can remember the order of the sequence. So the first one is the mode in, and values are 0 through 7. The next one is the number of degrees per step. The next one is, what is the next one? It's the number of rotations, so 1.0, 0.5, 0.25, what have you. The next one is either clockwise or counterclockwise, and the last one is the speed of rotation. So as you can see, this file can be really long, and just as long as you want to make it, and this will act as a program, if you will, for the stepping motor. So the other program, the Python program we just looked at, will come and execute this data, and this data becomes the program for the stepping motor. Okay, so that's it for the data file.
Well, let's look and see what this does. Let's do a demo. Okay, well, the star of this show is the stepper motor, of course, and in the background you can see the commands it's being fed. And let me get it started. And you can see it going clockwise, counterclockwise, faster, slower, big steps, small steps. all pre-programmed from the file, just reading one line from the file at a time. This is half a turn very slowly. Let's half a turn quickly. Well, that's it for this software upgrade. It's going to be good for, if you're doing pre-programmed lighting, light show, theater, something like that, or you're building a robot, or perhaps you've got your own Mars Rover. Okay, well, that's it. Hope you find it useful and interesting.